Let's learn the derivative of inverse of cosine. If y equal to cos inverse of x, then dy dx equal to minus 1 all over root of 1 minus x squared. Let's prove how we arrive at this. Y equal to cos inverse of x, that becomes equation 1. And from trigonometry, x equal to cos y, this becomes equation 2. Now we're going to differentiate implicitly. By doing that, we differentiate x to have 1, and then we differentiate cos y to have minus sine y dy dx. Now we're going to make dy dx the subject, and then we divide both sides by minus sine y, so that we'll have dy dx equal to minus 1 all over sine y, and this becomes equation 3. Now from equation 2, cos y equal to x, and that means cos y equal to adjacent all over hypotenuse from trigonometry. So that when we have cos y equal to adjacent all over hypotenuse, so from this we can draw the right angle triangle, and then the angle becomes y. So since cos y equal to adjacent all over hypotenuse, the adjacent becomes x and the hypotenuse becomes 1. Then we can let here to be n, and by using the Pythagoras theorem, we have 1 squared equal to x squared plus n squared. 1 squared equal to 1 minus x squared equal to n squared, so that n equal to the square root of 1 minus x squared. Here becomes square root of 1 minus x squared. Now, if cos y equal to adjacent all over hypotenuse, sine y becomes opposite all over hypotenuse from SOHCAHTOA. And that means the opposite becomes this all over 1. So we now have the square root of 1 minus x squared. Now, we are going to substitute the value of sine y, which is this, so that dy dx equal to minus 1